All right, so here is a video for the review for assessment number 4. So this graph here, when you're looking for zeros and factors. Remember, zeros is another name for x-intercepts. So zeros, roots, solutions, and x-intercepts, those all mean the same thing. And so when I look at there, the zeros are -1 and also 2, which turns my factors into x plus 1 and x minus 2. All right, over here, number 2, I'm looking for changing from here to here. So that means that you have done a reflection for the negative sign. The x minus 3 moves you to the right 3, and then up 4 for that 4 in the end. All right. Down here, number 3. If x equals -3 is a 0, so that means there's an x-intercept at -3. So right here at -3. That also means that the factor was x plus 3 that it came from. So let's read these. Which one can be true? Letter A, the y-intercept is 0, -3. Nope, it's supposed to be the x-intercept. The solution of h of x equals 0 equals 3. No, because it's supposed to be -3. And letter C, there it is, a factor. All right, number 4. Two factors are x minus 1 and 2x plus 7. So that means you have a quadratic of x minus 1 multiplied by 2x plus 7, and that's your polynomial, or your quadratic. So that means that your answers, or zeros, were 1 and -7/2. They're the things that made this equal to 0. All right, number 5. So on number 5, you have an old problem from before. Like the other tests, and so you have to know how to do some of those things as well. So g of f of x, this is composition. So I'm going to take f of x and put it into g. So g is the boss. I have something squared minus 4 times the same thing. So that something that I'm squaring is f to x minus 1. All right, so I'm going to go and square that to the side. 2x minus 1, if I square it, means I'm multiplying it by itself. So I'm going to FOIL it out. 2x times 2x is 4x squared. Then 2x times -1 gives me -2x on the inside and the last. So when you clean that up, you get 4x squared minus 4x plus 1. And then here I'm going to multiply out -8x plus 4. All right, so clean that up, you get 4x squared minus 12x plus 5. And that's your final answer. All right, for letter B, f of g of -2. So you're able to plug -2 into g to figure that out. So -2 squared minus 4 times -2. I'm plugging into this problem to figure that out. So that comes out to 4 plus 8, which is 12. So now this answer is 12. So I'm really asking myself f of 12. So that means I'm doing 2 times 12 minus 1. So 24 minus 1 is 23. Final answer. Number 6. Number 6, do not add the 5 and the 2. You're not allowed to do that. 2 is a multiplier. You have to get rid of the 5 by subtracting it. So I get 7 with x minus 3. We got 8. That's not right. Oh, that's a 2. Sorry. So divide both sides by 2, which leaves you with x minus 3. It's greater than 4. So you split this up. Solve each one. Add 3. 7, add 3 here, get -1. So there's your answer if you graph it. Okay. All right, for number 7. Number 7 is asking again about the zeros and the roots and the solutions and all that kind of stuff. We got x-intercepts here and here. So the factors turn into -5 turns into x plus 5. That's where it came from. And 2/3 turns into 3x minus 2. All right, this notation on number 8 is talking about the inverse. So the inverse of a function is when you switch the y and the x. So remember, this is y, so I'm going to switch it. I get x equals -4y plus 5. So I go subtract 5 because I'm going to solve it for y again. So I get x minus 5 equals -4y. Divide everything by 4. -4, that is. All right, this is gone. So my answer, I get y equals, but I should really put g -1 of x equals, and here's my answer, -1/4 x. And the next part is -5 over -4, so plus 5/4. That would be my answer. Alrighty. Number 7, I'm going to label all the important points first. So the right side is positive infinity and negative infinity. The left is negative infinity and also down. And the vertex here is negative 2 and 4. All right, the domain. Domain is negative infinity to infinity because that's the smallest and the largest x value. The range are the y values. It goes from negative infinity to 4. All right, and increasing. So this whole left side of the graph is increasing. So that starts happening at negative infinity and stops happening at negative 2. So negative infinity to 2. Negative 2, that is. All right, and then it picks back up at negative 2 and starts going decreasing. So that goes all the way to positive infinity. So the decrease is negative 2 to positive infinity. All right, x-intercepts. So I see this thing crossing the x-axis at negative 4 and also 0 right there. So negative 4, 0, and also 0, 0. Well, 0, 0 is also the y-intercept, the origin. It's on both. As x goes to infinity, the end behavior, the graph goes down right here. As x, I'm sorry, that was this one. And then as x goes to negative infinity, this one, the graph goes down also. All right, my equation, it's upside down, so negative. When I check it, there is no stretch or shrink because the graph starts here and goes out 1, down 1, out 2, down 4, and out 3 and down 9, and so forth. So it follows the correct pattern for a quadratic. So there's no stretch or shrink. It's moved to the left 2, and then up 4. All right, for this factoring part, your teacher may have done factoring differently than I'm about to show. So if they did, then you can go see them, or can see if this way helps you. All right, so I'm looking for something that makes 18 and also gets 7. So if I use 9 times 2, that makes 18. And if I do negative 9 plus 2, that also makes 7, negative 7. Because there's a simple 1 in front of here, so it's not a difficult problem. Over here, I got 2x squared, and 2, 9, and 10 have nothing in common. So 2x and x. I'm going to break 10 up into 5 and 2 and see if that works. I can't put the 2 with the other 2x, so I'm going to put 5 here and 2 there. Check it out. 4x, 5x. If they're both negative, then I will get a negative 9, and then I still have positive 10. All right, this last one here is perfect squares. So split up my 36 into 6x and 6x. Split up my y's, and 1 plus 1 minus, so it all works out. All right, this next guy. These all divide by 2 and x, so I'm going to pull that out. Leaves me 2x squared minus 3x minus 14. So when I go to factor that, I got 2x and x. 14, I'm going to use 7 and 2. So I got to put my 7 here and my 2 there. That gets me 4x and 7x, which could be negative 3 if the 7 was negative and the 2 was positive. All right, in the center, 15, 19, and 6 have nothing in common, so I'm just going to factor. I'm going to try 5x times 3x for my 15. And 6, I'm going to try 3 and 2, so I can't put the 3 in the back, so put 3 here and 2 there. Let's check it out. It's 10x and 9x makes 19. I'll just make everything positive, and it all works. Over here in the end, 12 is made by 6 and 2, 3 and 4, 12 and 1, but those don't make 5, so this is prime. All right. Here for this next one, I don't see a number on the end, so I'm just going to look see if they have anything common. They do. They divide by 3x. So once I pull that out, it leaves me 3x minus 8, and that's all I can do. Same thing happens here. 12 and 75 divide by 3, and also x squared I can take away. So when I do that, though, I get 4x squared minus 25, and then I notice those are perfect squares. So I keep going. One of them is 2x plus 5. The other one is 2x minus 5. All right, over here on the end, I notice they have a 5x in common, which leaves me x squared minus 7x plus 1. And I can't factor that anymore, so I'm finished, because nothing that multiplies to 1 makes 7. All right, here, your teacher might, this whole row right here, you may or may not have done this in your class yet, so if you didn't, ignore it and just move on to the next page. If you are in my class, we did this, so you're responsible to know it. I'm going to split this one. These two, they have a 9x squared in common, which leaves me with a 2x plus 3. These put minus, these two have a 4 in common, so that leaves me with a 2x plus 3. So I take out my 2x plus 3, which leaves me with 9x squared minus 4. Well, 9x squared minus 4 can be factored more. So 2x plus 3 And that factors again into 3x plus 2 and 3x minus 2 for a full credit. All right, the next problem. These are perfect cubes. So I have a binomial and a trinomial. I'm going to have 2x because that makes 8x to the third. I have 5 because 5 times 5 times 5 is 125. I do my square, multiply, square. So square the 2x, I get 4x squared. Multiply 2x and 5 together, 10x. Square the 5, you get 25. And then remember, you do your SOAP. Same, opposite, always positive. This back part here, it never factors again, so you don't have to worry about it. You're done. All right, on this last problem, 54 and 2 both divide by 2, and they both divide by x there, so I'm going to pull that out, which leaves me with 27x to the third minus 1. And now I notice these are perfect cubes. So 2x, so you have to pull the GCF out to notice. So this is made by 3x and 1. So square multiply square, I get 9x squared. Multiply 3x and 1, I get 3x. And then 1 squared is 1. Then same, opposite, always positive. All right, last page. So now I'm solving by factoring. So I got to move my 24 to the other side. So I have x squared plus 10x minus 24 equals 0. So when I factor, I get x plus 12 and x minus 2 equals 0. All right, so remember, I'm looking for answers. I want to know, when is x plus 12 equal to 0? When is x minus 2 equal to 0? Because if these two things multiply to 0, one of them has to be 0. So this answer is negative 12. This answer is 2. So negative 12 and 2. All right, last one over here, take away 15. I'm going to get it in standard form, 5x squared minus 23x minus 10. All righty. So I factor into 5x and x, 5 and 2. Put my 5 here, my 2 there. That's 25 and 2. So my 25 is negative, 2 is positive. So this produces an answer. It's equal to 0 at negative 2/5. This one produces an answer of 5. So negative 2/5 and 5. All right, over here, I'm going to pull everything to the left. So minus 2x squared. Minus 2x squared, and then minus 7 minus 7. So I get 9x squared minus 25 equals 0. I want to get everything 0 on one side. All right, so these are perfect squares. I got 3x plus 5 and 3x minus 5. So this produces an answer of negative 5/3. And this guy produces an answer of positive 5/3. So we can be fancy and just put plus or minus 5/3 for my answer. All right, last one, negative 6x squared. And then, so that's going to be x squared minus 10x. This 25 is just going to come over and become positive 25. All right, so when I factor, I get x and x, 5 and 5. And they both need to be negative to make my negative 10. So these two, when I set them equal to 0, they're going to produce the same answer. So I get x equals 5 for my one answer. Usually you have 2. Every once in a while you get something called a double root. So that means 5 is the answer twice. So what's happening is on the graph, it's coming down, touching at 5, and going right back up. It's not passing through the x-axis. That's a double root when it bounces off and goes back. All right, last couple problems here. Number 12, wanting this in standard form. So standard form is when everything's like multiplied out. It's not in factored form. So I need x times x. I got x squared, and then plus 2x, minus 5x, minus 10. So f of x, if it's in standard form, is x squared minus 3x minus 10. All right, and last one here. I'm going to have to tell you my transformations. The 2 is going to stretch the graph. So normally the graph would have gone from the center, would have gone out 1 and up 1, or down 1. It would have gone out 2 and up or down 4, and then 3 would have gone to 9. But I'm going to have to stretch that. I'm going to have to multiply everything by 2. All right, it goes to the left 3 and down 7. So let me go left 3 and down 7, and here I am. Now I'm going to go out 1. I would have gone normally up 1, but I'm doubling that to 2. And I would have gone over 2 and up to 4, would have gone right there, but remember I have to double everything, so I'm going to go up 4, 5, 6, 7, 8. And so then that repeats itself on the other side. I don't think I have space to do anymore because it's going to double 9 and get 18, so I don't have space to go up 18. So I'm going to draw my parabola and call it a day. Hopefully yours looks better than mine. All right, and that's it. I'll see you in class. Bye-bye.